Good morning. So I think you are very lucky today that you start with mathematics. You didn't start your day with mathematics. Yes, don't you feel so?
Yes, I do.
Yeah, good.
Because
Okay.
brain works.
So you will have a very good day probably. Yes? Okay, so let us start continuing our discussion about exponents. So we learned two types of exponents. So I told you that a number, if A is a real number, this means A belongs to the set of real numbers. And then we learned what to do with if n belongs to the set of integers. Yes, do you remember? This is the set of integers. And then you feel free to move around because I have to write all the board. If you cannot see it, you can just move around without any problems. Okay, so if A belongs to R, n belongs to Z, then we were able to talk about a to the nth power. Yes, so we call this one the base and this one the exponent, and the whole expression we call it an exponential or a power. Yes, of course we need to consider three scenarios. Yes, if n is positive, because you know that when you say the set of integers, what are these numbers? They start from negative infinity, for example, minus 3, minus 2, minus 1, and then you have 0, 1, 2, 3, and then continues forever. So we just learned how to talk about these numbers as the exponent. For number 1, do you remember what we said? We said that a to the power of 1 is a itself. Yes?
Yeah.
A to the power of 1 was defined a. But if n is a natural number and n is greater than or equal to 2, so it means that for this one, we realize what to define. And now I want to tell you how to define if n belongs to this part. If n belongs to that part, what was the definition? Do you remember when I say a to the n? It means
A times A.
a times a. How many times?
N times.
N times, yes. And then we realize immediately that this definition doesn't make sense for negative exponents, yes? For example, if I write a to the power of 3, it means a times a times a. A multiplied by itself 3 times. It makes sense. But if I ask you calculate a to the minus 3 using the same definition, it is ridiculous. Yes, it means to multiply a by itself negative 3 times, which is not nonsense. But do you remember how we defined that? So if I told you, so if you want to calculate a to power minus n, if n is again a positive number, so I'm considering these negative numbers, how should I define them? Do you remember? Not how should, how we define that. Yes? How did you do that? Yes?
One.
Just everyone. Yes? 1 over a to the n. Yes? 1 over a to the n. So this is clear. So if I have these numbers, the definition is this one. If the power is 1, if the exponent is 1, the definition is this one. If n is some number from here, the definition is this one. And do you remember how we defined a to the 0? Because, so you see, I considered all these cases. Now I want to consider this one. We define something for that. Yes? It's 1 by definition. But here and here we have 2 exceptions. Do you remember? Because here I have mentioned a can be any real number that you like. So far so good, so far so good. But for these two, there is an exception for a. A cannot take one single value, and that value is 0. So here, for these two cases, a shouldn't be equal to 0. For this one, it is obvious, because if a is equal to 0, the denominator becomes 0, and division by 0 is forbidden. But 0 to the 0, I would call it undefined. But even if you see some books define it to be 1, especially in computer science, okay? But the reason that I want to define a to the power of 0 to be equal to 1, we can talk a little bit about this later, okay? But for the time being, these are the rules that you need to know, okay? And I gave you some examples to calculate these things, and then I think that was very simple. Now we want to invent some rules, okay, or discover new rules for the exponents. So the first thing that we want to show is this. So let me just try to, instead of proving it rigorously, let me just motivate you why this is the case. For example, if I give you 2 to the power of 5, and if I ask you to multiply it by 2 to the power of 3, what does it mean? Of course, if I ask you to calculate or evaluate this, what is the final number for this? You have to calculate 2 to the 5 by multiplying 2 by itself 5 times, and if you do that, it becomes 32. And then I ask you what is 2 to the 3, you do the same, you multiply 2 by itself 3 times, it becomes 8. And then you have to multiply 8 by 32, and then you get 256. And that is the final number for this. But now I am changing my strategy. I am not asking you to evaluate and give me the final number. I am asking you to write something in front of it as a exponential. Okay, so that's my goal. Yes? 2 to the power of 8. So is the question clear? So there are two ways of asking questions. I can ask you, evaluate this, what is the final number? Then you can give me 256, that's 100% correct. Even though that's correct, now I am teaching you something new. I am teaching you, if sometimes we don't need to calculate. So as for example, I told you this example. If I ask you, for example, to calculate this, for example, of course you can calculate this 256 and then you calculate this by multiplying 2 times, 6 times. Again, it turns out to be 256, and 256 but 256 is equal to 1. Yes? But you have to calculate. But if I have a rule, now assume that if these numbers are very big, this way of calculating becomes very hard. It's in principle possible, but practically time consuming. Yes? For example, if I give you 100, I don't know. Let me make this 100, 2 to the power 100, and then let me keep this as it is. And then I divide it by 2 to the power of 99 and 2 to the power of 4. Of course, in principle, you can calculate 2 to the power of 100 by multiplying 2 by itself 100 times. And by the way, you have a very high respect for this guy now, yes? Remember, 2 to the power of 64 was so huge, let alone 2 to the power of 100, yes? But anyway, if you can calculate this, you multiply them, and then at the end you see that these numbers are equal, and then you divide them, it becomes 1. Okay, but the new rule that we want to discover here, we don't really need to calculate that. Without calculating this, using these rules that we are going to discover, we can immediately answer this fraction is equal to 1. Yes? Why? Because what was the rule that you are following? So let me tell you here. What is the meaning of 2 to the power of 5? So your friend told that the answer to this is 2 to the power of 8. We want to understand this equality. Is it true or false? Yes? Why is it true? Because 2 to the power of 5 is a symbol that we use for this product. Yes? Do you agree? 2 to the power of 5 is a short way of writing this product. Yes. And then there is a product again, so I put a dot here. This product is coming here. And then 2 to the power of 3 means 2 times 2 times 2. But if you do not look at it and you see this product, this is a product of 2's multiplied together. How many 2's you see in this list? 8. Yes? So then it is clear that the answer should be 2 to the power of 8. Is that clear? Okay. So the rule of thumb is this. If you want to multiply two exponentials so that the bases are the same, what is the rule? Yes?
You add the exponents together.
Okay, so you say you keep the same base and add the exponents. So that's the rule. Yes? Is that right? Okay. But my question is that, do you think that this is also valid if I have negative exponents? For example, do you think, so 2 to the power of minus 5, let me multiply it by 2 to the power of minus 3. So, do you think the same rule will apply here? What does it mean? here, let me clean this. How did I come to 2 to the power of 8? I wrote 1, 2 here, and then I added the exponents. But of course, because it was simple, I did it in my head, and then I wrote 2 to the power of 8. Okay? If you ask me what is the value 2 to the power of 8, I again tell you 256, but the logic is not to calculate the number at the end to understand this equality between exponents. Yes? Okay, now if this rule, we don't know yet, because here was a little bit trivial. Here I have 5 2's, here I have 3 2's, I am multiplying them. How many 2's I have? I have 8 2's, so it becomes 2 to the 8. Yes? But do you think the same rule applies here? Yes. 2 to the power of minus 5 is different. I cannot say multiply 2 by itself negative 5 times, yes? But do you think the rule is still okay with this? If this is okay, then what do you expect for the answer? You expect that you have this and then you add it with the next exponent. I don't know if this is true or not, but I want to convince you and myself that might be this is also true. Yes? If this is true, then this becomes how much? Minus 5 plus minus 3. What's the answer?
Minus 8.
Minus 8. So what we are trying to convince ourselves about is if this equality true or false. Yes? How should I convince myself that this is true? Yes, please.
We can start by putting it into a fraction, so 1 over...
Okay, let me step by step. You are right. So you are telling me that I start from the left-hand side, which is this guy. Okay, just tell me, what should I write for this?
1 over 2 to the power of 5.
Okay, so this is not hard to understand because there is only one way to answer negative powers. There is only one formula for that, one definition. So that's, I cannot do anything else except this. Okay, then I have this dot, meaning multiplication, and then instead of that, I will do the same. Yes? Okay, then how do you proceed?
Then you can simply remove the top for now and see that it's basically 2 to the power of 5 times 2 to the power of 3.
Not remove. If I ask you what type of number is this, this is a fraction. Yes? If I ask you what's the numerator, you would say 1. What's the denominator? So what you said is correct, but you really don't need to say that we for the moment we remove. If I have this is a fraction, this is a fraction, my goal is to multiply two fractions, and I know the rule for multiplying fractions. What the rule is?
Top times bottom.
Tops should be multiplied together and bottoms the same. Okay? So what I do, I will multiply 1 by 1, and then I will multiply 2 to the power of 5, 2 to the power of 3. But every one of you knows that 1 times 1 is 1. We just discovered that this rule is applied for this case. Do you agree? This is positive, this is positive. Definitely this rule applies for positive exponents. So now I can use that rule, and what can I write here? 2 to the power of 8. So you see, I am using the previous fact for the new one. And then, of course, this is completely okay, but if I want to write it as a negative power, can I write it as a negative power? This fraction?
Yes.
Yes? You see the rule here. Of course, most of the time, we prefer to make a negative exponent to a positive exponent. But because this is equality, it doesn't matter. Sometimes I can go the other way if I want to. In this case, I want to. So can I write 2 to the power of minus 8? Everybody happy with that?
Yes.
Okay. And then what is this one? This is the right-hand side. Yes? So you see that even though it was very trivial, very simple to understand for positive exponents, but it was a little bit more tricky to understand that this is also true for negative exponents. So do you agree with me? So this is something that if you want to learn mathematics, you need to train your brain in this way. Because this is true, there is no guarantee that this is also true. Do you understand what I mean? For example, right now, if I ask you, do you believe in this? Yes, you shouldn't believe just blindly. Yes? The reason is that If I ask you what is the meaning of this, you might not be able to answer this right now. Okay? What is the meaning of 2 to the power of 1 over 2? Yes? 2 to the power of 2, you know. 2 to the power of minus 2, you know the meaning. But what the meaning of 2 to the power of 1/2, still you don't know. And if you don't know what the meaning of this power is, there is no guarantee that the same rule that you used for these powers will also apply for this kind of powers. Yes? Mm-hmm. Is that understandable?
Yes.
So this is a very tricky point to understand in mathematics. Every step that you are going to take should be based on logic. Okay, this is why if you discover something mathematically now, and it is true, it will remain true forever. This is the main difference between mathematics and other parts of science, yes? For example, Newton discovered the gravitational law, okay? And then 300 years later, that actually Einstein actually realized that this is, of course, was very good approximation, but what was not the whole truth. Yes, so we changed that. And of course, Newtonian physics was very good to make for buildings, I don't know, cars, even airplanes, but GPS system is not using Newtonian mechanics, it's using Albert Einstein mechanics. So if you do not use those physics there, then GPS is actually more or less useless. You will end up somewhere which is kilometers away from your real destination. Okay? So, but this thing cannot happen in mathematics. It's like a chess game. So if you know the rules, you can play chess. At least you can imagine you can, in principle, be able to play chess even 1 million years from now, if you want to follow the same rules. Yes? It might be a very boring for that civilization there, but I don't know. But at least you can imagine that you can still play that. This is the same thing in mathematics. So be careful. Because this is the most important weakness in actually novice students. They take things for granted. They say that if this rule applies, and this rule applies, so why not for that? But this is different, yes? Okay. But the good news is that this rule also applies, but the proof is beyond, probably a little bit beyond, the Math 1C lesson. So then you have to trust me on that. At least you know that. You know the reason for that. You know the reason for that. For the time being, if you trust your teacher, you also can use this rule. But if you are curious, this question should be in the back of your head, so to discover why this is true. Yes? So sometimes I can give you the reasons, and I will try to give you the reasons. Sometimes it is a little bit beyond the level of Math 1C, it needs more mathematics. So then I will tell you that you have to trust me for that, but this rule is okay again. Okay? We will come to this a little bit later. Okay, so let me just write this one for you as a rule. And I really want you to memorize the formulas after understanding them. Yeah, it's a very good practice for your memory. Okay, so what we have, if I have a to power m multiplied by a to power n, what can I write in front? I can write a to the power of m plus n. Yes? So if I have two exponentials with the same base, and I am supposed to multiply them, then I write the same base and I add the exponents. So what I told you is very, very important. So I don't know, might be some of you are interested in poetry or something. When you read a poem, okay, so sometimes you need to understand the deeper meaning to that poem. Okay, so that's the same thing for mathematics formulas. So if you see this formula, you should be able to talk it in your own language. For example, let us consider English here. So when I see this formula tells me like something like this. If you want, you see all these sentences, if you want to multiply two exponentials with the same base, you can write the same base and add the exponents. So this is the deeper meaning of these symbols that you see on the whiteboard. Is that understandable? So you should be able to interpret. Okay, so for example, I don't know, if I want to give you, by the way, do you think I can extend it for more than 2 exponents? For example, I have 2 to the power of 2 multiplied by 2 to the power of minus 4 multiplied by 2 to the power of 8. Can I use the same rule for 3 exponentials? It is clear I can do it one way. So what would be the answer? It would be 2 plus minus 4 plus 8. So what would be the answer? 2 to the power of 6. If I ask you to calculate, to evaluate this, you have to write 64 in front. But if I ask you write this expression and as one exponential, this is the end of the solution. You stop there. And most of the time, I'm not asking you to evaluate, because evaluate probably might need calculator. You have to punch a lot of, if the numbers are big. But if the numbers are small, I can also ask you to evaluate. But most of the time, I want you to be able to write this is equal to this. So instead of having this, which is actually a longer expression, I can have a more compact expression. And it's extremely important in mathematics that you are able to simplify things. Okay. Let me ask you some question. By the way, it's very important. Usually, there are 2 types of questions. Simpler questions, the left-hand side is given to you. You are supposed to write the right-hand side. From this direction to that direction usually is simpler for students. But this is equality. When you say this is equal to this, it means that whenever this is given, if you want to, you can take it off and put this instead. Or the other way around. If someone gives you this, if you want to, you can take it away and put this instead. So be careful. When I write equality, sometimes we need to go in this direction. Most of the time probably we need to go in this direction. But sometimes for harder problems, we need to go back in this direction. Okay, let me give you an example here. How do you solve this problem? I tell you that 2 to the power of x is equal to 4. I give you this piece of information, and I will ask you what is 2x to the plus 3. And I ask you, can you find the number to this? So what would be your answer? Yes? 2 to the power of 5, which is 32. So how did you come to this conclusion? That's correct conclusion. Yes?
Because 2 to the power x is 4, and I did in my head that 2 to the power of 2 is 4. So now that I know x, I just did 2 plus 3, which is 5.
Okay, so what you said yourself, you said to yourself, from this piece of information that Babak provided to me, for me, I will conclude that x is equal to 2. And then when I know x is equal to 2, I don't have any problem because I can replace this x by that 2. And then what happens? It becomes 2 to the power of 2 plus 3. Understandable for everyone? Okay, and then it becomes 2 to the power of 5, and then you can, for example, write 32. Okay? So, for example, if I ask you what is the value of this, I prefer you to write 32, not 2 to the power of 5. But let me change my question. Let me change my question in this way. 2 to the power of x is equal to 3. Yes? And then I ask you the same question. So you see, this was super simple to solve, and you come up with the answer immediately. You see, I didn't change anything except I changed 4 to 3, and I'm asking the same question. Okay? Now I just want to know, how do you answer this new question? Yes, please?
3 to the power of 3?
3 to the power of 3? No.
No.
But you got close. The way that you thought, if I'm right, is right, but you made a miscalculation, I think. I think the way that you thought is correct, if if I understood it correctly. So at least do you feel the difference between these two peoples, but these two problems? By changing 4 to 3, the same strategy fails to work. The reason is clear. Because at least, even if you have calculator in your hand, you will not be able to answer this exactly. There is a fancy name for this number. You might think, is there really a number so that when I raise 2 to the power, it becomes 3? It's not evident. Yes, 2 to the power of 1 is 2, but 2 to the power of 2 is 4, but 3 lies somewhere between 2 and 4. So what I can conclude, what can you say about this x? X should be somewhere where? Somewhere, yes? Between 1 and 2. But who knows how much? Yes, how much? Yes. Just wait a moment. So do you agree? This number, if it exists, if there is really a number with that property that 2 to the power is exactly equal to 3, then we know something about that number. That number is somewhere between 1 and 2. What is that number exactly? We don't know. Okay? And if you have your calculator, still you don't know. Because the calculator will provide you with the decimal points, which is an approximation to that number. This number has a fancy name that you will learn in Math 2C, and that is called the logarithm of 3 in base 2. Okay? So this number is a little bit strange. But you really don't need to know the topic of logarithms to be able to answer that. Of course, if you know this topic, you can still answer this question, but you really don't need to wait until you learn about logarithms to be able to answer this question. Now, yes, let me give you the opportunity.
Isn't minus 1.5 gonna work for x? Because
No.
2 to the power of
No.
1.5 is almost 3.
Almost is not my point. Yes, if I give you what is this number approximately, this idea is good. But I want to give me exact value. This is not useful for exact value. Another chance?
3 root, or how do I say it? You know this...
Third root.
Third root to the power of 3.
No.
No?
No, I just told you this is not the case. This number is not the third root. This number that you are looking is this number that you don't know yet. Okay? So you see, even though I explained this there, but you didn't use that. Because your brain, I know, because I have been teaching mathematics for a long time, so I know that, I don't know, from psychological point of view, for students, it's much easier to go from left to right. But most harder problems need you to go from right to left. Now, can you solve it? No? Think about it. I want to change your logic, you know? I want you to learn, you need to think, you need to change your perspective. Okay, every one of you trying to probably start from here to do something to reach to this question mark. Yes, why don't you think in the other way around? So your goal is to answer the question mark, yes? So your goal is to answer the question mark, because the question mark is 2 to the x plus 3. Not yet? Any answers? Okay. I will write it as 2 to the power of x multiplied by 2 to the power of 3. Is that understandable for everyone? This is what I told you. Sometimes I need to go in this direction. Yes? Yes or no? First of all, do you agree that this equality is valid?
Yes.
Because of this formula, but in the other direction. Agree or not?
Yes.
Okay, but is it a problem now for me? Yes, you?
No, because now we know what's to
Yeah, we know the whole package.
So,
Even though we don't know x yet, but who cares about x? What we need to answer this question mark is this package as a whole. And we know everything we need for that, and that is 3. Who cares about what x is? In this problem, x is not relevant. Of course, if you can find x, definitely you can answer this question mark. That is definitely one way, but that is not the only way. Is that understandable? Yes or no?
Yes.
Okay, so 2 to the power of x is how much? Is given to you.
3.
Is 3. And of course, no one needs to tell you 2 to the 3. What is that? 8. and then you multiply, so the answer to the question mark is 24. Okay, and that's the exact value. So this is why, please listen to, because I have a lot of experience in teaching mathematics. So when I emphasize something, there is a reason that I'm emphasizing on something, because there's something coming on. Okay, so that's good. Let me give you another example. I think this you can solve now. Let me give you this. 5 to the x is 20. Okay? And then I ask you to calculate this. 5 to the x plus 2 plus 3 times. Let me make it smaller for you because you don't have your calculator. I don't want you to use calculator. 10 is easier. And that actually have the same idea. So 5 times 3 times 5 to the power of x plus 1, and then this is the question mark. Okay, I want to wait for you. Okay, just answer this question. I will pause the recording. I'll wait for you. Okay, any ideas? Yes? What's your name? Hafsha? Yes?
First I have to start by working from the left-hand side to the right.
Okay, so you want to start from the question mark, yes? So the question mark is equal. I will follow you. So what should I write?
So we can break up the first exponential, so it's 5 to the power of x times 5 to the power of 2, and then we just plus 3 times 5 to the power of x times 5 to the power of 1.
Very good. And now it becomes clear for everyone. Yes, is that understand? This kind of writing, is that understandable for everyone? Yes. So you see that I am using the other direction. Remember, usually harder problems is the other way direction because you need to be careful. So exactly, very nice way of writing and breaking things up. If you have any questions, please let me know so far. Clear for everyone? Yes, do you have questions?
Do you calculate the exponent first or the multiplication first?
Which one do you think we should do?
Like 3 times 5 to the power of x. Like do you calculate x first or do you,
No, it doesn't matter because this is a product and product. So in products, it doesn't matter if you multiply a by b first and get the result and multiply it by c. If you multiply by b by c first and multiply it by a, or even if you multiply a by c first and then multiply it by b, it doesn't matter. Okay? But if I give you this, still you want to do this. It doesn't matter which one you multiply first. But if you want to multiply 3 by this, you need to know the number first. So automatically you have to do the power first. Yes? But here it doesn't matter because I want to replace 5 to the x by 10. Okay? But your question is valid. If you mean, if I want to calculate this, what should I do? Definitely, when you multiply, when I can ask you, you don't need to memorize. If I ask you to do this product, this multiplication, I need to give you this number and that number, and then I can ask you multiply them. So when I give you 3 and I give you 5 to the 2 and I ask you multiply them, so this number should be clear for you first. So this means automatically you have to do the power first. Yes? Is that understandable?
I understand.
Yeah. But here, this we don't need to be worried about this part at least here, because I will continue. Do I need to know, do I know x?
No.
No. Is there such an x? Yes, it's a little bit more advanced to understand the x, but who cares here, because my goal is to answer this question mark, and as far as this question mark is concerned, x is not my problem. My problem is the whole package of 5 to the x, which I know. Yes? So instead of 5 to the x, what do I put? I put 10. And what is coming after that is 5 to the 2, which I know the number, which is 25. And then I have a plus. And then I have 3. Instead of 5 to the x, again, I can replace 10. and then 5 to the 1 is just 1. And this calculation is very simple. This becomes 250, and this becomes how much? 150, and I want to add them. So the answer is 400. Yes? Is that understandable? Yes or no? Good. Okay, again, even because let me just use a little bit of my experience. Sometimes I have seen students do such mistakes. So this rule applies only here for product. Okay? So if I have 2 to the power of 5 multiplied by 2 to the power of 3, I'm allowed to write 2 to the power of 8. But what can I do for this? Can I do something for this?
No.
So I am changing the multiplication to addition. I just want to make sure that you understand this rule only works if I have a product. This rule does not apply here. If I insist to do something with it, what is the only thing that you can do? Yes?
To calculate the numbers and then
Yes, and then add. So for addition, that's the only thing that you can do. There is nothing that you can write in front of it. Okay? But let me start doing some games together. Okay? So do you think this is valid or not? Let me make it first simple. I want to write a strange equality in front of your eyes. Do you agree that this equality is true or false? If this is true, why? If this is false, why? Yes?
It is false because the value of the exponent is different from each other. It should be x plus, and the solution should be 2 to the power of x plus x.
No. You are inventing a new rule. Yes? I told you just right now. So let us repeat this. You see? So you need to trust me. I have experience in teaching. Yes? So you told me that 2 to the x plus 2 to the x is 2 to the power of x plus x. Do you agree now?
Yes.
This is what you said. I just mentioned this, you remember, I told you that 2 to the power of 5 times 2 to the power of 3 is 2 to the power of 8, but 2 to the power of 5 plus 2 to the power of 3, what can I write in front of it? And that is exactly the thing that you use, yes? So yeah, trust me, when I emphasize something, I'm actually using my statistics, my data, yes? Okay, so this is not working, yes? Okay, now again the question is still remained. Is it true? Why? Is it false? Why? You wanted to answer something? What's your name? Okay. What? Your name, Tim? Okay. So you don't want to answer your name?
Eric.
Eric. So, yes? What's your opinion? True or false first?
True.
True, and why?
Well, I just gave the x the value of 0,
Yes?
and then the equation makes sense because
Yes?
the 2's all become 1's because 2 to the power of 0
Yes?
is equal to 1. So it's 1 plus 1 equals 2 to the power of...
Okay, so your reasoning is based on is an example.
Yes.
But this is not a good mathematical reasoning. This is also good to know. This is a scratch paper work. So you work on this, you give your example for yourself to see that it works. But be careful. Even if you bring me millions of examples for which this equality is true, this is still not true for every x. Because if you want to, if you check it for 1 million x's, how many x's that you haven't checked is left? Infinitely many more. That is why physics might change in the future by advancing technology, but mathematics will not change if you prove something. Because when you say this is true, it means that this remains true forever. It doesn't matter if you continue calculating from now until the end of the universe, you will not find even one single contradiction. So be careful. These are very important things that you need to learn here. If you want to prove something is true in mathematics, even bringing millions of examples showing this works is not enough. But if you want to refute, if you want to say something is false, even bringing one example that does not work is enough. Be careful. Remember this. If you want to prove millions of examples is not good, millions of examples gives you this idea, might be this is true, but might be, it's not 100% clear. But if you want to if you want to refute something, if you want to say that this general statement is not true, it is enough to bring one single example to show that this is not true, and that single example has a particular name for it. I think I told you before. What was the name of that example? It's famous term in mathematics. That's called, you know, counterexample. Yes? So that's called a counterexample. Okay? So what you proved, what you showed is that this might be true because it is working for 0. Another friend of you say that it might be true because I also checked it works for 2, for example. Another one can say it might be true because I checked it worked for 5. But all of them are just random checking. There are infinitely many possibilities, and we cannot check all infinitely many possibilities. We can only check finitely many possibilities. Yes? Is that understandable? Okay. So, now again, you? First, true or false?
True.
Okay, what's your reasoning?
Because they have the same exponents, first of all. So their final answer, that like the two values that need to be added together would be the same. And adding the same values together is almost like multiplying it by 2.
Almost no, exactly. Yes.
Multiplying by 2, which we're doing because the base is...
Exactly. So let us, so did you hear what she said? She said that it's true, and I agree with her, but a little bit in a strange way. Why? If I give you a pen, and I give you another pen, how many pens do you have? 2. That's completely clear. So I just want you to trust your own knowledge. So here, what is this guy? I don't know. This is something, and I have the same thing again, and I am adding them. I have a package, I have another identical package, adding on top of that. How many packages do I have now? How many packages do I have?
2.
2. So, I start from the left-hand side. So, let me write it again. The left-hand side is this one. I write in front of it 2 times 2 to the x. So, first of all, do you agree that this equality is true? Yes?
Yes.
Who wants to explain again why this equality is true? Yes? There is no denominators here.
Oh.
Now, why this again? I explained it. I am asking you to explain it again. Yes? What's your name?
Because Oscar.
Oscar, yes?
Because adding 2 of the same values, basically, it's exactly the same as multiplying it by 2.
By 2, yes? Is that understandable? 5 plus 5 is 2 times 5. 7 plus 7 is 2 times 7. Box plus another box is 2 times box. It's 2 boxes, yes? So this one added to itself is 2 times itself. Is that understandable? But now, can you tell me, what is the exponent of 2?
1.
1. So this is not written. Let me write it dotted line. So this is a 1, which is actually concealed there. So now if I ask you, can I use this rule? Because I am multiplying 2 exponentials with the same base. So the rule is to write the first one, the base as it is, and add this exponent to that exponent. But is there any difference between 1 plus x and x plus 1? No. So if you want, you can continue and write 2. And instead of 1 plus x, you can write its equal value. And then you reach to the right-hand side. So you see, it was a little bit a strange rule, but it worked. So this is a mathematical reasoning that we got from the left-hand side to the right-hand side. So this shows that you will never ever find a counterexample, because independent of, regardless of the value for x, this works. You see, I didn't consider the particular value for x. I told to myself, whatever x is, this reasoning work. Yes, so it means that I am done for all possible x's, and this means that's a mathematical proof. Yeah, is that understandable?
Yes.
Yes or no?
Yes.
You have questions? Yes.
No, I just want to say that I meant the base, not the denominator.
Okay. Yes. Yes. Now I know that because probably you haven't heard these words in English, so you have to learn them. I think it's better to have put them in this Anki. I told you that it's really important to set up the Anki account as soon as possible. Okay, is that understandable for everyone?
Yes.
Okay. Now let me make a little bit nicer question. Okay, so. So let me write, because I'm intentionally writing this sentence because in the exam you need to get used to what I'm writing. So example, write the following number as one exponential or as one power. So the number that I have already designed is this number. So let me write it for you. 6 times 2 to the power of 8, okay, plus 5 times 2 to the power of 9, okay, and then plus 6 times 2 to the power of 7, and finally minus 24 times 2 to the power of 5. Okay? So, let me explain what do I mean. Of course, I will write another one for you after explaining. So you see, this is a number. If I ask you to evaluate, and I let you to use your calculator, that's not a big deal, yes? So what you need to do is to type this in your calculator and press the execute button, you get the final number. Is that right? So that is not my goal. Okay? My goal is to simplify this expression into another form. This is a skill that you really need to learn and to master. So what I mean, try to find a way to reduce this into one term, one expression, so that you have a base and you have an exponent. Yes?
Can't you like add two bases of 2 together?
No. Listen to me. You are not listening. You are not allowed to invent new rules in mathematics. So why do you think this rule should work? Just because you want it. So it's very, very important. I know that this is the most important problem in teaching mathematics. People are somehow inventing their own rules. Yes? And this is, I don't know, this is not hard, because all of you, if you want to send an email, you know which application to use. So if you want to send an email, do you use the recording application? You use probably your browser, or so you have to do exactly the thing that you need to follow. So you cannot say, why you think we can add these two?
Because if we were...
No, because, so what, again, let me ask you again. So what was your answer? Your answer was, for example, do you think you can do something with these two terms only?
No, but the 2 to the power of 8, and then you add it up, so it becomes, so you can remove, you can add up all the exponents.
No, we cannot do that, can we?
Together.
No, there is only one way that you can add the exponents. What is that? If I have this expression, then you can add the exponents. This is true. But my point is that because this is true, why do you think, is this expression here identical to this expression?
No.
No. So if that's the hard part of mathematics, if that is even slightly different, the rule might be totally different. So you cannot apply the same rule for something very similar. Even very similar doesn't work, yes? It should be identical to the rule that you have, or you need to invent a new rule with mathematical reasoning and use your own rule. That is also correct. But if that's not the case, you are not allowed to use it. This is a very important point. Yes? I always tell my students is that if you know that you don't know, is better than you don't know and you don't know that you don't know. This is a very hard one. Because if you don't know and you know that you don't know something, you go for it and learn it. But if you don't know and you don't know that you don't know, then you're happy that you don't know. Yes? So be careful about these things. Okay, now I want to wait a little bit for you to see that how. Now I want to give this chance to everyone again. Okay? So please try, take your pen and paper and then try to work this out. And below this, I will start to write another one which is harder. Because if you do not succeed this, I will explain this to you and then I will expect you to be able to solve a harder one because now you are a little bit more experienced after the first one. Yes?
Can you look if this is correct?
I will come to you. Okay, so let me, everyone thinks about that. So let me write another one item here for you. Yeah, please start working on it. So this was item number 1. So this is item number 1. And item number 2. Light speeds, good idea. Because these I have already designed them, so.
Also werde ich so enden.
Yes? Even if you have some hopes to calculate 2 to the power 5, I hope that you will give up here. Yes? So this is why I made it a little bit harder. Okay, so I give you 5 minutes to think about this. If you couldn't, I will try to explain this for you. Then I will expect you to be able to solve the harder one, because after that you have more experience. And that's the goal. More experience, harder problems to solve. Yes? So 5 minutes. Everyone, you can collaborate together. That's also very good. Learn to start working in groups, you know. Okay, so what happens? What was your name? Sorry. What was your name? Simon. Okay, so do you want to explain your idea, Simon? The first one?
So I began with trying to get the same like exponent in the exponential, so I then can.
So you see, he's explaining it very nice. He's also explaining his strategy to tackle the problem. You see here, the reason that I was able to go forward is because I have the same package 2 times added, so I wrote 2 times. Yes? So that was actually, you see, I cannot give you all the examples. But you need to keep in mind the main ideas. The main idea why I was able to go forward here, because I am adding the same thing to itself 2 times. Okay? The problem is that, first of all, I do not have the same packages. 2 to the power of 8 is not the same package as 2 to the power 9. Let me ask you this question. If I have given you this, everyone should be able to answer this. What can I write in front of this? Yes, Ali?
11 multiplied by 2 to the
Yes.
power 8.
Why do you hesitate? Because I have 6 of something, 6 packages, and I have 5 more of the same package. So how many packages do I have now? 11 packages, yes? So this, you shouldn't doubt about this. The answer is 11 times 2 to the power of 8. If you don't understand, ask me again. Is that understandable? Don't look at this. Consider this is a box. If this is your box, do not look inside. This is the same thing. So that's the same box. I have 6 boxes plus 5 more boxes. Then how many boxes do I have? 11 boxes. So if I ask you this question in this way, you can answer. But if I ask you this question in this way, you might get confused. The skill and the art in mathematics is to understand your own knowledge. So if you can answer this in principle, you should be able to answer this in this way. Do you agree with me? Okay. Now this problem is still harder than this one, because the packages are different. I have 5 of these packages, 6 of these packages, 2 to the 8, but I have 5 different packages because the other package is 2 to the power of 9. It is like that I have 6 glasses and 5 pens. I cannot add them. Yes? Is that understandable? So the first thing comes to his brain, and he actually explained it very nice, to make the packages more or less the same. Okay? So can you just explain how?
So firstly, I consider that the easiest option is to either remove one exponent from 2 to the power of 9 or add one exponent to 2 to the power of 8 to make them equal.
Very, very nice explanations. Thank you. I'm enjoying that. Okay.
So I went with the option to add 1 to the 8. So then I simplified the 6 to...
It's a little bit more advanced. Okay. Yeah. Thank you very much. So, yeah, very good. So you realize that the obstacle in front of me, there is no obstacle in front of me here because they are of the same packages. Here I have 2 to the 8, 2 to the 9. If I want to proceed, there is only one way. Either make the packages 2 to the power of 8 for this one and that one, or make the packages 2 to the power of 9 for this one and that one. Yes? Then I can go forward. Okay? And you said which one you have chosen?
I went to increase 2 to the power of 8 to 2 to the power of 9.
Okay. This is a little bit more technical, but he did it. He realized this 6, yes? I saw your solution. He realized that this 6 is a product. 3 times 2. Yes? So in your head, everyone knows that this is 3 times 2. So you see, it is important how you use your own knowledge to succeed to solve a problem that you haven't seen. Every one of you, I'm sure you know that 6 is 3 times 2. But might be you don't see it relevant here. By this way of explanation, I hope that you understand the ideas. So why this is good? Because this 2 will multiply itself by this to the 8, gives me 2 to the power of 9, which is the same package I see here. Okay, so let us follow. Let us see what happens. And you really don't need to anticipate the problem until the very end. You need to start with small pieces, stick them together, and then you will see the grand picture. Yes? And by the way, most of the time this will fail. You have to go back and redo everything again in a different way. If you don't like this way of thinking, don't work with mathematics. So mathematics is like that. The number of problems that we can solve is much, 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 much less than the number of problems we cannot solve. Okay? So here, we go here. So I will follow him. So if the first term, if you have questions, let me know. Do you agree that this expression can be replaced by what I have written here? Everyone agrees or not?
Yes.
If not, I can explain again. Yes or no?
Yes.
Okay. Let us go back. Do I need to do any changes here?
No.
No, because my strategy is to making them the same package. This is already 2 to the 9. So why should I change it? I just copy and paste it. You see, if you know what you are doing, you can follow good strategies. Okay, so what can I continue now? How should I continue for the second, but for the third one?
Then you can also divide up the 6.
Divide up the 6, but might be this is a little bit strange because I will get 2 to the power of 8 instead of 2 to the power. But let us see how it works. Who cares? You don't need to be worried about everything in one step. So here I will write it 2 to the power of 3. But what can I write now? Tell me, everyone. What's the answer now? It's plus
3 multiplied by 2 to the power
8. Yes? It might be a little bit of deviation from my main strategy. Yes, because I produced 2 to the 8. Okay, let us see what happens. Let us continue. But now, everyone else except Simon, do you know what should I do? If you know the strategy, you understand what is going here. So what should I write for 24? If you are following the strategy, there is a natural way to break 24 up. Yes, please, what's your name? Merk, okay.
3 times 8.
3 times 8. Why? Because 8 itself is how much?
2 times 2.
2 to the power of 3. Is that understandable? And then 2 to the power of 3 will combine itself here. It becomes 2 to the power of 8. Okay? So now we have 2 packages, 2 to the power of 8, 2 packages, 2 to the power of 9. Yes? So what we can do, we can write minus 3, 2 to the power of 8. Everyone with me? Okay. Now, can I add these two? Yes or no?
Yes.
Why? Because I have 3 package, 5 the same package. What is the answer to this first 2? 8 of the same package. Agree? Now can I subtract these 2?
Yes.
Yes, actually, because they are of the same package. But I have 3 packages. I gave all my packages to you. I am left with no packages. Is that understandable? 3 of these packages minus 3 of these packages. So it's gone. So what's the answer to this?
0.
0. Yes? So I don't need to write 0. So the answer would be 8, 2 to the power of 9. First of all, it's extremely important to improve your skill in this simplification. That's an art in mathematics. So you see this expression so long, 1, 2, 3, 4 terms, can be written more compactly as one single term. Yes or no? Okay, so if you ask me what the number is, of course I have to calculate the number at the end. But without calculating the number, I was able to show you that this expression, whatever it is equal to this expression. I can still do better. I can write it a little bit more compactly. If I write it 2 to the power of 12, do you agree with me?
Yes.
Yes? Why? Yes?
Because 8 is 2 to the
Power of 3, and then I have 2 to the 3, 2 to the 9, I write 2 to the power of 3 plus 9, 2 to the power of 12. And by the way, according to the demand of the problem, if you stop here, you will lose some small points. You have to end up here, because I have written to you, write it as one exponential. And that is your exponential. Is that understandable? So this is the goal of high school mathematics and more advanced mathematics. So you should be able, when you learn something, you should be able to do some simplifications in that area. Yes? Now that you have a little bit of more experience, you know at least how I was thinking, how Simon was thinking very brilliantly here. So might be you can solve a harder problem. Okay, that's the goal. I teach you something. If I want to give you the same thing, this is useless. It seems that I am giving you the same Sudoku table over and over again. Is it fun to solve the same Sudoku table every day? No. You need to solve new problems. Okay? So I will give you again 5 more minutes so that you can do the same thing for the harder expression down there. And be free to use your creativity. Okay? Okay, did anyone come with an answer to this?
Yes.
What is the answer to this? Just the final answer.
3 to the power of 4.
3 to the power of 34. What do you think, Rasmus?
I got 3 to the power of 35.
35. So, but at least it is completely clear. All of you are on the right track. Others? No progress? No progress? Okay, so take this one as a home assignment if you are interested in solving these kinds of problems. I will stop the lesson now and we will continue. The next time that I will teach you, I will start from this problem. Yes? Okay? Thank you very much.